This video is intended as an overview for experienced heating professionals. Refer to installation instructions for complete information. Always follow all safety precautions and good service practices.
Refer to manuals and supplements for complete details. Disconnect power and close the main manual gas valve when removing components for service. Welcome to the Carlin EZ Gas Troubleshooting Guide. Remember, for safe and dependable operation, all EZ Gas burners must be properly grounded back to the power supply panel and have correct polarity. Before we begin troubleshooting, let's walk through a normal burner cycle so we know what to look and listen for. Self-test 1 is performed each time power is applied to the primary control. About 4 seconds after power is applied, the amber LED turns on. The test continues for about 6 more seconds. The control enters standby mode if there is no call for heat. When the manager receives a call for heat or hot water, self-test 2 begins. The manager's burner light turns on, the amber LED turns on. The motor starts and pre-purge begins for about 30 seconds. The igniter starts after the pre-purge period. 2 seconds later, the gas valve opens. After the gas valve opens, listen for combustion. The green LED turns on at the end of the TFI period if the flame rod senses flame. The burner continues firing during the call for heat, and the green LED remains on during normal running. This video will help guide you through some of the common causes and solutions relating to the EZ Gas burner motor not starting, the burner not lighting, and the burner lighting but locking out after trial for ignition. If the burner motor won't start, begin by confirming that the digital manager power light is on and there is a thermostat call for heat or hot water. Check the voltage and polarity at the convenience outlet located on the manager junction box. Confirm the fuse or circuit breaker is on at the main panel. Make sure the emergency system and burner toggle switches are on. Is the green circulator light on the manager on? If so, the burner main circulator relay should be closed and sending 120 volts AC to the burner and circulator circuits. Is the burner light on the manager on? If so, the dry contacts inside of the manager are closed and completing the circuit to the primary control's TT terminals. Check for 120 volts AC at the boiler high limit, the low water cutoff, and the Frontier boiler door switch. Also, check the voltage and polarity at the primary control's black wire and red with white stripe wire to neutral. If the primary control is in lockout, the red LED will be on. To reset, press the red reset button down for 1 second and then release. The red LED will go out and the control should start. The problem that caused the burner lockout must be corrected before returning the burner to normal operation. If the primary control is in latch-up, the red and amber LEDs will both be on. The control enters latch-up if a lockout occurs 3 times on the same call. To reset, press and hold the red reset button down without releasing. After about 10 seconds, the red and amber LEDs will begin flashing alternately. Continue holding the reset button down for about another 20 seconds. The LEDs will turn off. Release the reset button and the control will restart. The problem that caused the repeated burner lockout must be corrected before returning the burner to normal operation. Check all wiring against the diagrams in the installation manual or the manager junction box label to confirm there are no issues with incorrect wiring. The primary control's red with white stripe wire should be connected to a constant 120 volts AC power supply from the double pole burner switch. Check primary control operation by providing a call to the manager and check for 120 volts AC with a meter between both the black wire to neutral and then the red with white stripe wire to neutral. If the burner light on the manager is lit, but the motor does not start, install a jumper across the TT terminals. If the motor does not start, check for 120 volts AC between the orange motor lead and neutral. If there is no voltage to the motor lead, the control is defective and needs to be replaced. To check for a defective motor, Disconnect the motor leads from the primary control and apply power directly. Replace the motor if it fails to operate. If the burner motor starts but the burner won't light, begin by checking the airband setting against the gas burner settings table found in the EZ Gas Burner Manual Supplement for Energy Kinetics. The final settings will be determined by performing a combustion test with the airbox cover installed. Also check the orifice size against the gas burner settings table found in the EZ Gas Burner Manual Supplement for Energy Kinetics. Install a manometer on the inlet side of the combination gas valve to check supply pressure. If there is no pressure, trace the gas line to find out why there is no gas available. Check the main manual gas shutoff valve as it may be closed. The minimum inlet gas pressure is 5 inches water column with the burner firing and all other gas appliances operating. Next, check the combination gas valve outlet pressure. The manifold pressure should be between 3.2 and 3.8 inches water column. Primary control operation should be checked by measuring voltage between the violet gas valve lead and neutral lead during the trial for ignition period. If 120 volts AC is not present during TFI, replace the control. Perhaps the issue involves the gas valve not opening. Check the gas supply pressure at the gas valve inlet. If the pressure is in excess of 14 inches water column, it will cause the valve to lock up. Also, check that the gas valve is receiving the correct voltage during the trial for ignition period. Remember, in 2014, a 24 volts AC gas valve replaced the previously used 120 volts AC valve. If the correct voltage is present, with the inlet pressure below 14 inches water column and the valve still won't open, replace the gas valve. If correct voltage is not present, use a voltmeter to trace the gas valve circuit. Burners with a 24 volts AC gas valve have a 24 volts AC transformer that is supplied with 120 volts AC from the primary control's violet wire. Measure voltage with a voltmeter at the primary control's 120 volts AC output on the violet wire to the transformer. Next, check for 24 volts AC from the transformer, then through the burner airflow switch, the blocked air inlet switch, and the blocked vent switch to find the break in the circuit. You can accomplish this by disconnecting the gas valve lead from the transformer and inserting a voltmeter test lead directly into the transformer lead. Then touch the other lead to each terminal in succession through each safety switch in series as shown. Trace the circuit by touching a voltmeter test lead to each switch terminal with the other voltmeter test lead on the transformer lead. The series safety switch circuit is the same on burners with the 120 volts AC gas valve, but without the transformer. The burner airflow switch is normally open and will close when the burner fan operates. The blocked air inlet switch is normally closed and will open if the air intake becomes restricted. The blocked vent switch is normally closed and will open if excessive back pressure exists in the boiler or vent system. So check for flue blockage or air infiltration into the flue. If light off is still an issue, you should check the igniter cable connection to the spark electrode and the position of the igniter electrode. For correct settings, see page 3, figures 4 and 5 in the EZ Gas Burner Manual Supplement for Energy Kinetics, and adjust if necessary. Also check the primary voltage to the igniter. If 120 volts AC is present to the igniter and it doesn't generate spark, replace the igniter. If the burner lights but locks out after trial for ignition, begin troubleshooting this condition in much the same way as if the burner wouldn't light. Check the airband setting against the gas burner settings table found in the EZ Gas Burner Manual Supplement for Energy Kinetics. The final air settings will be determined by performing a combustion test with the airbox cover installed. Also check the orifice size against the gas burner settings table found in the EZ Gas Burner Manual Supplement for Energy Kinetics. Check the gas valve outlet pressure. it should be between 3.2 and 3.8 inches water column. Check the line pressure at the gas valve supply pressure tapping. Gas pressure must be at least 5 inches water column with the burner firing. Adjust the regulator if the pressure is less than 5 inches water column and do not exceed 14 inches water column. If other appliances are on the same line and the burner inlet pressure drops more than 1 inch of water column at light off when they are operating, the gas line is undersized. Some other factors that can cause the burner to lock out after TFI include poor draft and an insufficient flame signal. With poor draft, excessive positive pressure over fire during the burner pre-purge or immediately after the light off may cause the block vent switch to open the gas valve circuit, resulting in a lockout. To improve draft, tighten the front and back boiler covers, seal all air leaks into the vent system, install a properly sized chimney liner, provide adequate air for combustion, and properly set the burner excess air, just to name a few items. See our video on draft solutions for more information. For insufficient flame signal issues, the flame signal at the test jack on the 60200 FR primary control must be at least 0.8 microamps DC. If the signal is lower, check the flame rod, porcelain insulator, and the flame rod wire and connections. If the flame rod is grounded in any way, the control will lock out after TFI. The flame rod may be touching ground, the insulator may be cracked, or contamination may cause a path to ground. Inspect and clean if necessary and verify the flame rod position on page 3, figures 4 and 5 in the EZ Gas Burner Manual Supplement for Energy Kinetics. Adjust if necessary. You must also check the polarity of the power supply. If the hot neutral wires are reversed, the flame rod circuit cannot sense the flame correctly and the primary control will lock out after the trial for ignition period. A continuous copper ground must be in place from the power supply panel to the burner junction box for reliable sensing of flame by the primary control. All installations and repairs must be made in accordance with all state and local codes, which may differ from this guide, and in accordance with the following codes as applicable.